Welcome to the new era of video creation with Bozzy 8. Today, we will discuss the difference between batch processing and online learning in machine learning. Can you explain the difference between batch processing and online learning in machine learning? And when would you choose one over the other? In machine learning, there are two fundamental ways to update and train models: batch processing and online learning. In batch processing, a model is trained on the entire dataset at once, which makes it suitable for situations where the full dataset is available at the beginning of the training process. On the other hand, online learning allows the model to update its parameters incrementally as new data arrives, making it well suited for scenarios where data is streamed or comes in continuously. The key difference between these two approaches is that batch processing works with static datasets, while online learning can adapt to changing data over time. Choosing between these two methods often involves a trade-off between efficiency and adaptability. While batch processing can be more efficient when handling large fixed datasets, online learning provides more flexibility in situations where data is dynamic and constantly evolving. Batch processing is typically used when the entire dataset is available before training begins. The advantage of batch processing is that it can be computationally efficient because the model processes the entire dataset at once, utilizing techniques like parallelism and vectorization for optimized computation. However, one of its main limitations is that the model requires the entire dataset in memory, which can be impractical for large-scale datasets. Another downside of batch processing is that updates to the model are not immediate. Once the model is trained, it can take a long time to update, as it requires retraining on the entire dataset. For instance, if a new batch of data comes in, the model will need to process the entire dataset again to incorporate the new data. This makes batch processing less efficient in environments where frequent updates are necessary. Online learning, unlike batch processing, allows the model to be updated incrementally as new data comes in. This makes online learning memory efficient, as there is no need to store the entire dataset. It's particularly beneficial when working with large-scale datasets or in environments where the data is continuously updated or streamed, such as in real-time systems. One of the key advantages of online learning is its fast adaptation to new data. As data continuously arrives, the model can instantly incorporate the new information, making it especially useful in dynamic environments. However, online learning also introduces some risks, such as the potential for drift in the model's performance over time. For instance, if the model is exposed to noisy data or outliers, it might adjust too quickly to these fluctuations, which could degrade the model's overall performance. Batch processing is often the best choice when working with fixed datasets that do not change frequently. For example, image classification tasks often rely on batch processing, especially when training complex neural networks such as convolutional neural networks, CNNs. In these cases, the dataset can be pre-processed, and the model is trained all at once, leading to more efficient and faster results. Batch processing is also suitable for tasks where less frequent updates are sufficient, such as in data analysis or scenarios where the data remains static for extended periods of time. Big data systems, such as those used in data warehousing or ETL processes, also tend to use batch processing for tasks like aggregating and transforming large volumes of data. In these contexts, it is more cost-effective to process data in large chunks rather than trying to process data as it comes in. Online learning is ideal for use cases where data is continuously being generated or when the environment is dynamic and ever-changing. Examples of these applications include real-time data systems such as sensor networks, stock market prediction, or autonomous vehicles, where the model needs to adapt in real time to new observations and trends. Additionally, online learning is excellent for applications like personalized recommendation systems, where the model can adjust based on a user's behavior over time. For instance, a music recommendation system would benefit from online learning, as it could continuously learn from a user's preferences and suggest more relevant songs without retraining on the entire dataset. Lastly, online learning is also valuable in situations where resource constraints limit storage and computation, such as edge devices in IoT systems. When comparing batch processing to online learning, one of the primary differences lies in the size of the dataset being used. In batch processing, the model is trained on the entire dataset at once, while in online learning, the model updates with each individual data point or small batch. This makes online learning more adaptable to real-time changes in the data, allowing the model to continuously evolve. From a computational efficiency standpoint, batch processing tends to be more efficient in scenarios where the model needs to process a static dataset, because it allows for large-scale operations like matrix multiplications that can be parallelized. However, online learning can be computationally expensive over time, as the model must be updated continuously. The memory usage also contrasts significantly. Batch processing requires a large amount of memory to store the entire dataset, while online learning is much more memory efficient, processing one data point at a time without needing the entire dataset. One of the main advantages of batch processing is its ability to efficiently handle large datasets, as it can leverage techniques like parallel processing or distributed computing to speed up the computations. This is especially useful for training complex models, such as deep neural networks, where a large volume of data is needed to capture intricate patterns in the data. Batch processing also offers stability in learning, as the model is trained in a single phase using the entire dataset, which helps smooth out fluctuations that might occur with incremental learning. Additionally, tuning hyperparameters is easier because the entire dataset is available, which allows for better understanding of the model's performance and fine-tuning the model's settings. Online learning offers significant advantages in dynamic environments where the data is constantly changing. It can adapt to new data points as they arrive, making it particularly useful for real-time applications. For example, in financial trading systems, the model needs to process new market data and adapt to emerging patterns without waiting for the full dataset. Another key benefit is low memory usage. Because the model processes data one point at a time, or in small increments, it doesn't need to store the entire dataset. This is ideal for environments where storage is limited, such as with edge devices or in resource-constrained scenarios. Furthermore, online learning provides real-time feedback, allowing the model to update itself instantly based on the new data it encounters. The choice between batch processing and online learning largely depends on the characteristics of the data and the specific needs of the application. If the data is static and does not change frequently, batch processing is often the better choice due to its efficiency and ability to handle complex models. On the other hand, if the data is dynamic or continuously evolving, online learning is more suitable as it can adapt in real time to new information. Another consideration is resource constraints. If the system has limited memory or computational power, online learning may be preferable because it doesn't require storing large data sets. However, for large, complex models that need to be trained on vast amounts of data, batch processing is usually the better option, as it allows for parallelization and more stable learning. In conclusion, both batch processing and online learning have their strengths and weaknesses, and the choice between the two depends on various factors such as the data characteristics, system resources, and the complexity of the tasks involved. While batch processing is more efficient for large, static data sets and complex models, online learning is more adaptable, memory efficient, and well suited for real-time dynamic environments. It is important to choose the right method based on the specific needs of the application, balancing efficiency and adaptability for optimal performance.